Well, good afternoon, everyone. I've kind of come to commit a massive fraud here today because I'm not actually talking about SDR. What I'm talking about is the user interface to SDR, which is a rather simpler problem. So let's start with what we wanted to do. SDR gives you a way to get high-performance radios and particularly to get some innovative features that would be quite hard to have with an analog radio. And a lot of those are the kind of things we've already been hearing about today. A lot of the implementations that are available to us use a PC as the user interface. And for some people, that's absolutely fine. But for other people that have been brought up using a radio that have knobs on the front and push buttons, that's still what they want to use. And Kjell and I have independently found that our friends, when it comes to a contest, they want to use the old style radios, and they might accept that software-defined radio could give better performance, but if it's not the user interface they're used to, that's not what they're going to use. So my question was, why do we have to choose? Can't we have both? Well, ICOM's already shown us that yes, we can. Any radio that's been made in the last 10 years, or probably quite a bit more, is already computer controlled. All of the controls on the front just go to a computer, and that then sets the either RF or digital hardware. So all we needed was something similar. And this isn't original. John Melton's already shown us how to do this. His PC SDR program has connections for knobs and push buttons, so that you can have tuning knobs and knobs for some of the other analog controls, push buttons for others. And he's described how we could use cat commands to control a PC-based program that was described 3 years ago, I believe. So all we needed to do was to make something similar. To control a PC, we don't have hardware input, so we would have to do something different. We have readily available to us Ethernet and USB, so we've had to come up with another way. So what is it that we've actually done? We started off by surveying the user interface requirements for a whole load of radios, and essentially what kind of controls do they provide. That wasn't a greatly useful exercise, it turns out, because each manufacturer has their own favourite layout of controls. And as the years go on, the approach varies. So the FT1000 is the third radio down in that stack. Every control that is available, with a small number of exceptions, just about every control that you could possibly use on that radio is available on the front panel. Over the years, manufacturers have started getting away from that because the front panels were just getting too crowded. A modern SDR from Flex Radio Systems at the bottom has got relatively few controls on it. They've worked out that their operators tend to want a few controls for each channel that they're using. So what I did was to watch a contest through the 24-hour SSB field day. And he used almost none of the controls on his FT1000. There's a whole load there. He used the tuning knob, obviously, very occasionally the receiver independent tune, and almost all, well, not all the time, but quite often, the variable passband tune to get rid of interference, either at the bottom or top edge of the signal in a crowded band. And apart from those and changing mode, all of the rest of the controls were set up to the settings that he wanted and then left alone. So you don't actually need all that many controls available to use at the time. If you can make the settings and then leave them, that tends to work. So what we came down to was wanting a few controls. One of the critical things was a good quality tuning action, because if that's not there, it won't be usable. So what was it that we would use? Well, the bit on the right is given to us. PowerSDR is a commonly available PC program to control radios that connects via Ethernet to the radio, and we then had to connect somehow to our controls. Our controls quite easily interface to a microcontroller, and we've also provided a touchscreen display. And the recommendation from John from his previous work, and when we talked to him about this project, was to use cat commands that connect direct to PowerSDR. PowerSDR already interprets those, so all that we would need to do is essentially send ASCII characters over a serial port. Well, that's quite easy to do at the microcontroller end. The critical thing that we needed to get right was the tuning action. If you remember that FT1000, I regard that as the benchmark, as what my friends want to be able to use. If it doesn't look and feel like the tuning action of that, they won't use it. Well, the FT1000 tuning knob's got 500 or 600 steps per revolution of the tuning knob, so that's 500 or 600 increments of frequency. And it's quite a heavily weighted knob. You can flick that and turn it at about 4 revolutions a second, so somewhere in the vicinity of 2,500 steps per second, and the system keeps up with that. But if I use these cat commands, I would have to send to step the frequency down by 1 step, 7 ASCII characters. So to step VFO down, VFOA down by 1 step, you have to send ZZAD01 semicolon. Well, at the fastest rate I can send those, that takes about 600 microseconds. I'm getting tuning steps in from the knob at about 1 every 400 microseconds, and it can't keep up with that. So very quickly you would start to get a lag if you put all of those into a queue, and as soon as you've got a lag, when the knob stops moving, your frequency on your radio is still turning. So we needed a different solution. So the observation that I had was that an analog radio doesn't retune its synthesizers at that rate. It can't do it because they would never settle. What it does instead is tune the synthesizers much less often and then just nudge them to the side one way or the other. So what I decided I was going to do was to have the radio tune every 100 seconds, every 100th of a second, every 10 milliseconds. And what it will do is count how many steps the tuning knob has moved in the last 10 milliseconds, be that 0 steps or potentially 20 or 30 steps, and then move the VFO frequency once by that number of steps. The outcome's still the same. You turn the knob, the frequency moves by the right amount. As you tune through another station, the thing sounds kind of the same as an analog radio when you tune through another station. It's just done a different way. The only catch is PowerSDR doesn't have any commands to tune by n steps, so I would have to add some. Well, it's not hard to download the code, and the design tools are all free. So I downloaded those one Saturday morning and started having a look at the code. Well, the command to step down by 1 step is ZZAD. So having loaded all the code, used the facility to do a search all the files in the project for the string ZZAD, and very, very quickly I found what the structure of the software was. We start off on the left-hand side. There's an XML file that just gives you a list of all of the commands and how many characters are in each command and things like that. Very simple structure. It just tells the program what commands are available to it. The next bit of code just breaks all of the incoming commands up into individual messages, so it will interpret ZZAD01 semicolon as step VFOA down by 1 step and pass that on to the next piece of code. And the third bit of code for each of the commands, once it's broken that down to a particular command, tells it calls a particular function to implement that. So I was able to find the function that implements tune by 1 step and make a similar one that tunes instead by n steps. There's only about 15 lines of code there, so it's quite simple. So I've only had to change 3 individual files in the program to add those commands. I did get a bit carried away, so having added the 4 that I needed to step up and down VFOA and VFOB, actually I added a few more while I was at it. Those are the ones on the left-hand side here are all released in the 3.4.9 release of PowerSDR. We have a few more to get into a future release where we've added the ability to set the diversity controls as well. So that's got PowerSDR ready to work with some alternative user interface. The last bit was to actually create it. So we've got a set of components. We've got an optical encoder for the main tuning knob. Those are quite high quality things. Used to cost about £100 a piece or 120 euros, but they're readily available for less than 10 euros on eBay now. We've used simple mechanical encoders for the other controls and push buttons. I found a touchscreen display that was quite easy to work with from a company called, well, the brand name of the display is Nexium. And we've used the well-known Arduino family of microcontrollers with the code in that essentially connects all the controls and gives me the serial commands to go out to the PowerSDR program. Kjell created a PCB to put all of those things together, and I had to then write a few lines of C code to make it all work. So what have we ended up with? What the end result is a box that you can liken to being a keyboard that you connect to your radio. So as well as having a PC keyboard connected to your PC, you would connect one of these, and this then controls the PowerSDR program. We've got a tuning knob which you can flick at the same kind of rate you can the FT1000, and then other controls for other things. We've got on here 17 push buttons and 8 other encoders. You can make it with more or make it with less or whatever, and the touchscreen display. Main display shows a lot of the common settings that you want to have, so that if you want to use this as an alternative display, you can operate the radio just looking at this. If you want to use your PC with the PowerSDR display as the main display, you can do that as well. You can choose which one you want. All of the controls are customizable, so if you want this knob here to be the AF gain, you can do that. If you want that to control the attenuator settings instead, you can change that over. There's a menu to be able to configure all of those. But we can do something new with this. In a multi-operator contest, you're generally allowed to use a second receiver if you have one available to you. Well, operator 1 can have one of these consoles and operate VFOA to make contact with all of the stations during the contest as normal. But in a lot of radios, we've got another receiver and VFOB available to us. We can plug in a second console, still using the one radio, the one copy of PowerSDR, and the second operator can use their own display, their own set of controls, to search for other stations or to find out whether it's an appropriate time to change bands or something like that. So it's given the ability to have a second person operating as part of that contest. With the same radio, all you need is another one of these. If you want one of these, first of all, you can make them. All the designs are on GitHub, and the GitHub web addresses will be on the slides. All of the details of how to build the hardware is there, and the software, and all of the display code that you need to download to the touchscreen display. Or Apache Labs will eventually be supplying them. Kjell's made 3 variants of this. We've got this one with the larger display, which is for those of us like me that can't read things very well anymore. The large screen display is actually quite good, but we've got one with a smaller display as well. And he's also produced a small mini version that we've made using lower cost single encoders. You can use the dual encoders as well. But you can get the component cost to make this down to around about €100 or so. So where do we go from here? At the moment, what we've created is something that is critically tied to PowerSDR. It only works with that one program because of the extra commands that we've added into PowerSDR. If we want to use it with a different program, I've already been asked today about are we supporting Thetis, we will have to add new commands to that program as well. Well, adding new commands to Thetis I don't think will be particularly hard because it started from the same code base. So I should be able to find the changes that I've made and then make similar ones. But what about another program? There's other manufacturers of SDR software that are quite different, and that would end up with the burden of adding extra commands to those as well. There is another possible way, and that would be to have some kind of an interface adapter. At the moment, when this knob is configured to be an AF gain control, it sends cat commands out over the serial cable that essentially says increase the volume of your radio using the command that the PC program recognizes. We could instead have sent out something that says knob 7 is being turned by 3 steps, or push button 1 is being pressed and push button 1 is being released. And that interpretation as to what that means could be done elsewhere. And it isn't clear what the right place in the chain is to do that. It rather depends how many other people and other programs are involved. If lots of people want to modify lots of different programs to do this, having an interface layer to a single command set might be easier. If there's only one other program to support, maybe just changing this is an easier thing to do. At the moment, that interface layer is essentially in the code in here. I start off with a piece of code that has got an ability to control the display, to know how far the encoder's been turned, to know when buttons have been pressed, and to be able to light LEDs. And there's just a set of device drivers for all those functions. Then I've got a layer of code that interprets those and generates the necessary commands to go out over the serial port. Well, instead, that interface layer could be somewhere else. It could be built into the PC programs, or it could be another layer that sits in the middle in the same way that DD-util apparently works. It's not clear what the right thing to do is. There are other approaches that could be taken from the one that we've used. So, lastly, a quick question. What was the most difficult aspect of this design? It could have been adding in cat commands into PowerSDR, for which I've had to learn somebody else's program. It could have been using the touchscreen display, where we have to create a description of the display and then interpret characters that come from that. Could have been writing the Arduino program. Well, none of those were actually greatly difficult. But sourcing the knobs that fit on the front of these encoders, next to impossible. There is no catalogue manufacturer, or there's no knob in a standard supplier's catalogue on this planet. We have found a manufacturer that makes one as a special, and that is now available, but it doesn't appear in anybody's catalogues. Luckily, we managed to solve that. Anyway, thank you for listening. I think we're finished a little bit early. We'll be taking... Thank you. We're taking these over to the HPSDR meeting over in another room on another part of the site, but anybody that wants to come and see the thing and turn the knob and have a go with it, it will be there.
Okay, we have enough time for questions now.
So the main difference between this and the Pi HPSDR is that the Pi HPSDR replaces PowerSDR and operates as a standalone, whereas this operates with PowerSDR, and I can see a lot of advantage in that because you can use your big monitors and have the big display and so forth. Would it be possible to use that hardware with your software?
To use which hardware?
The Pi HPSDR, yeah.
Because this is written for Arduino, which is quite a bit different. It could be done.
That's written for a Raspberry Pi or a Tinkerboard or whatever.
Yeah, it could be done. So, one of my plans with the new Linux software is to have the Raspberry Pi have a version of the code that's a thin client that talks to the server, so you could run it over the internet.
Yeah, because I mean I like that device, but you can't use it. It's a standalone device.
Uh-huh.
Thank you.
Any more questions? Can you please hand the microphone over?
For the knobs, have you looked at Tone Studio's equipment? Because they have the same problems. You're now working with software and you need control units. You can buy high-priced or low-priced China products. Normally they put media output, but media translation to cuts would be a problem. You could take these cheap devices, break it apart, and use their knobs.
Yeah, I know. I'm aware that there are some things of that sort. I didn't actually look at doing that because I wanted something that looked like the right kind of product.
Yeah, I think break it apart. But it's cheap. You can do cheap knobs and so on from these devices.
In a 24-hour contest, this is going to get abused. I want it to last.
Any more questions? No more questions? So then.
Well, you started off with an apology that this is not SDR and you doing the easy part of just supplying the user interface. As someone who's coming from projects with a lot of engineers that are in DSP and this kind of thing, actually someone sitting down, taking the time to figure out how to interact with software, how to interact with what you're building, this is tremendously hard. And I cannot express how much I appreciate someone actually doing that, because it's actually not easy. It's far from that. So thank you.
Thank you.